molecule. Basically it's a different type of bond between molecules that you haven't done before. Why this is important is I was going over some of your test results, your pre-test results, just to see where we are. And if you have a look here at this sample, don't worry, I'm not going to say any names, you'll see the big circles here, one here and one here. Okay, so now for this particular question you weren't supposed to balance the equation, so that was fine. But if we were having to balance this, we would never get that right, because hydrogen gas is not just one H. Oxygen is not just one O. Okay, so you'll run into all sorts of problems if you don't know that oxygen is O2 and hydrogen is O2. And how would you ever know that? Well, you might have learnt it by heart. The people who did get it right, I think you've sort of learnt that by heart. But why is it O2? Why is it H2? So we're going to go over that today. So far, what you guys have learned is that ionic molecules, I'll give you an example, sodium chloride. So if we have a sodium atom, we know that it's got a charge of +1, and that's because sodium lives right over here in group 1. So they have got one outer electron, or one valency electron, so they need to lose one, okay, to have a full outer shell. So that's exactly what sodium will do. It'll give away its valency electron to chlorine, or it could give away to numerous other options, but when it gives it to chlorine it forms sodium chloride, and it's a nice match because chlorine is -1, and we know that because if we go to the periodic table we see chlorine over here, it's got its group 7, it's got 7 outer electrons, it needs to gain just 1 electron to have a full outer shell. So easy peasy, sodium gives this electron to chlorine, which has got 1, 2, 3, 4, 5, 6, 7, and we have a nice ionic bond. Okay, but then what happens when we have compounds formed out of the non-metals? So ionic compounds are often the metals over here and the non-metals. So an ionic compound is a metal and a non-metal. What happens when we have these guys over here, oxygen, nitrogen, carbon, reacting with each other? Well, something different happens then. We get something called a covalent molecule. What that means is it's a shared electron, not a donated electron. Okay, so let's have a look at an example. Let's look at hydrogen over here. It's got 1 outer electron, so it needs 2 outer electrons to be fully stable. So let's draw our hydrogen over here. Let's draw another hydrogen over here. Let's just draw them to see what the problem is. The problem is both of them have only got 1 outer electron. They need 2 outer electrons to be stable. So have a look at what's going on here. We've got an electron here and an electron here. What if these could come together? What if they could come closer together and we could share them? Well, that's exactly what happens in hydrogen gas. So in hydrogen gas, we have a hydrogen and another hydrogen. I'm going to draw the electron for this hydrogen as a cross, not a dot, just so we can tell which one belongs to which. And we can see here that if they come close enough together, they can share an electron each, and then if you count the other electron as its own electron, then they have 2 electrons. So when we do this, this means that 2 electrons, 2 shared electrons equals 1 bond. Okay, so they have formed 1 bond. Whenever I see 2 electrons, I'm just going to draw a big line to show that there's a bond. So the reason I draw that line is because then we can really simplify this and we can show hydrogen like this. So we know that here is the bond, and one bond represents 2 electrons. Okay, let's do something a little more tricky. Let's do oxygen. So oxygen's a little trickier because oxygen's got 6 outer electrons. So if we draw oxygen over here, 1, 2, 3, 4, 5, 6, and then we draw another oxygen over here, 1, 2, 3, 4, 5, 6. Which ones can we share here? Well, if I look at the ones that are closest to this one, and this one, I can see that this oxygen on the right can get 8 outer electrons all together if it shares this one and this one. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and 1, 2, 3, 4, 5, 6, 7, 8. So let's draw it a little more clearer. 1, 2, 3, 4, 5, 6. And then I'll do my other oxygen nice and close. 1, 2, 3, 4, and crosses 5, 6. Okay, so every time I see 2 electrons, I'm going to draw a line. That's going to be my bond. So here's a line, and here's a line. So that means that this oxygen has got 2 bonds. That's what you call a double bond. So this can happen with our covalent molecules. They can form double bonds. Let's do one more. Let's do nitrogen. This is even trickier still. I'm going pretty fast here. Nitrogen has got 5 outer electrons. So nitrogen lives over here. It's got 5 outer electrons. 1, 2. No, I'm not going to draw it like that actually. I changed my mind. I'm going to do 1, 2, 3, 4, 5. And then if we put another nitrogen over here, 1, 2, 3, 4, 5. So let's have a look at this configuration. You can see that because it's got 5 electrons in the outer shell, so nitrogen needs 3 more to be stable, to have a full outer shell. So because it needs 3 more, that's why I put all my 3 shared electrons here, because I knew each one needed 3. So if I count all of these, 1, 2, 3, 4, 5, 6, 7, 8, I know that if nitrogen can borrow these or share these, it's going to be complete, it's going to be stable. So let's draw this the dot and crossway so we don't get confused with whose electrons are whose. 1, 2, 3, and then I'm going to draw another round circle here for my other nitrogen. 1, 2, 3, 4, 5. So this one's got 1, 2, 3, 4, 5, 6, 7. Oh, and I forgot to count that one. Is 8. And this one's got 1, 2, 3, 4, 5, 6, 7. Oh, and I forgot to count that one. So it's really nice to draw them close together, because see how I nearly forgot to count these ones because they were up there. So draw them nice and close together so you can share them all. It does get a bit squishy. Every time I see 2 electrons, I'm going to draw a bond. So these 2 are shared, these 2 are shared, these 2 are shared. What does that mean? It means that nitrogen has got a triple bond. So we've got 3 shared pairs of electrons. That's called a triple bond. That's why nitrogen is so stable. Nitrogen gas in the atmosphere, it makes about 80% of the atmosphere, and it doesn't react very easily with anything, because it's got a very, very stable, strong bond, triple bond. So triple bond is very strong. So I hope that kind of explains why hydrogen gas is not just one hydrogen atom. It's 2 hydrogen atoms, and the way they do it is 2 hydrogens share electrons. Oxygen gas is O2. Why? Because if we get 2 oxygen atoms and we share electrons, we can have a double bond, and that's oxygen gas. Nitrogen gas is N2 because 2 nitrogen atoms can share their electrons and form a triple bond, and be a nice stable compound.